11 beavers slipped into the dark water of a Scottish loch. Scientists knew where they came from, where they were going, and what they were supposed to do. For years they planned to monitor almost everything. It looked like one of the most controlled wildlife experiments Britain had ever attempted. But while those 11 beavers were being watched in the forests of Knapdale, another population was already spreading through Scotland without permission. Nobody had planned it, nobody had authorized it, and it was already changing the terms of the experiment. That second population would turn a cautious reintroduction into something far larger. A national argument about rivers, farmland, wildlife, and how much control humans are willing to give back to nature. Beavers had been absent from Britain for several centuries. They were hunted for their fur, their meat, and castoreum, a secretion once used in medicine and perfume. By the time modern Scotland began discussing their return, nobody alive had grown up beside a wild beaver. Bringing them back took years of surveys, consultations, objections, and political debate. Then, on the 28th and 29th of May 2009, 3 Norwegian beaver families, 11 animals in all, were released into freshwater lochs in Knapdale Forest on Scotland's west coast, the first phase of a carefully staged trial. The question seemed straightforward. Could they survive? But survival was only the beginning. Most animals adapt to the landscape around them. Beavers alter the landscape to suit themselves. They cut willow, birch, and alder. They drag branches into narrow channels and pack the gaps with mud, stones, and vegetation. The result can look rough, but its effect is precise. Moving water slows, spreads, and begins to pool. A stream that once ran through a single narrow channel may develop deep ponds, shallow edges, wet soil, exposed mud, flooded roots, and tangles of submerged wood. That physical complexity matters because every new surface becomes habitat. Dragonflies patrol above the water. Their larvae develop below it. Frogs use warm, sheltered shallows. Wading birds search the muddy margins for insects and worms. Deadwood offers shelter to aquatic invertebrates. Small fish find cover beneath branches. Bats hunt over open water at dusk. And where fish become more abundant, predators follow. Herons wait at the edge. Kingfishers cross the channel in a flash of blue. Otters investigate deeper pools and sheltered banks. This does not mean every beaver pond produces the same result. Some dams are temporary, some streams are unsuitable. Water temperature, oxygen, and sediment levels all vary by site. But across many studied landscapes, one broad pattern appears again and again. Beavers replace uniform channels with a mosaic of habitats, and that mosaic can support more forms of life. The value is not the arrival of one rare species, it is the multiplication of small niches. Fast water in one channel, still water nearby. Sunny shallows beside shaded pools. Living trees next to drowned trunks and fallen branches. A common frog needs something different from a salmon. A dragonfly larva needs something different from an otter. Beaver activity brings those conditions closer together, turning a short stretch of stream into several habitats at once. The water itself also changes. During heavy rain, water that would have moved rapidly downstream may be held behind several dams, spreading across floodplains, sinking into soil, releasing more slowly. In small catchments, this can delay and reduce peak flows. Beaver wetlands can also trap sediment and retain nitrogen and phosphorus carried from surrounding land. They are not a universal substitute for flood defenses, but they can add friction to a river system that humans have often straightened, drained, and accelerated. By this point, the Knapdale trial was proving something important. Eurasian beavers could live, feed, reproduce, and reshape habitats in modern Scotland. But this was not the most consequential experiment taking place. Far to the east, in the catchment of the River Tay, beavers were already living outside the official project. Their exact origins were uncertain. Some were thought to have escaped from private collections. Others may have been released illegally. They were not part of the Norwegian trial, and nobody had chosen where they would settle. While scientists followed a small number of animals at Knapdale, the Tay population was breeding across one of Scotland's most productive agricultural regions. This changed the question completely. Knapdale was testing whether beavers could survive in Scotland. Tayside was testing whether Scotland could live with beavers. In a forest loch, a flooded margin may become valuable wetland. In a field, the same rise in water can damage crops, block drains, and prevent machinery from reaching the soil. A tree cut beside a remote stream becomes dead wood and habitat. A tree cut in an orchard or commercial woodland becomes a financial loss. The same dam that slows water for people downstream may flood land belonging to one farmer upstream. That is the central tension in the beaver story. The ecological benefits may be widely shared, while the costs can fall on a very small number of people. Fish add another layer of complexity. Beaver ponds can create deep, cool refuges and provide cover from predators. Submerged branches support insects that fish feed on. A newly built dam can delay fish movement, especially during low water, and fisheries managers worry about access to spawning habitat for salmon and trout. The effects are not simply good or bad. They depend on the river, the season, the height of the dam, and the species involved. But public debates rarely stay that precise. To some people, the beaver became a symbol of ecological recovery, a native engineer restoring processes missing for centuries. To others, it was an animal protected by national policy, while local landowners paid the bill. For a time, Scotland managed that contradiction one conflict at a time. Dams were removed. Animals were controlled under license. Some were killed. But the population kept growing. In November 2016, the Scottish government announced that beavers would remain in Scotland. In May 2019, the Eurasian beaver became a European protected species under Scottish law. Protection did not mean every dam had to stay or every animal was untouchable. It meant that intervention now had to follow a regulated process. The response became more varied. Individual trees can be wrapped or fenced. Culverts can be protected from blockage. Pipes can be installed through dams to manage water levels. Where conflict cannot be resolved, entire families can be trapped and moved to catchments prepared to receive them. Lethal control still exists, but relocation has become an increasingly important part of the system, and this creates an unexpected reversal. The animals removed from one place as a problem become the founders of a restoration project somewhere else. By 2023, NatureScot estimated around 424 territories across Scotland, representing more than 1,500 beavers. New releases and natural expansion have continued beyond the original strongholds. The 11 animals released at Knapdale in May 2009 did not build that population alone, nor did they single-handedly prevent floods or restore every river they touched. Their real importance was different. They helped prove that the species could return. The unplanned population of the Tay then proved that its return could not remain confined to a scientific trial. Scotland began by asking how to release beavers safely. It ended up asking how rivers, farms, forests, fish, and people could share space with an animal that constantly redesigns its surroundings. That question has no final answer. A beaver does not restore one fixed version of nature. It creates change. More water here, less speed there, new habitat in one place, conflict in another. Several centuries after humans removed it, the beaver is again shaping Scottish landscapes. But the deepest change may not be happening in the rivers. It may be happening in the way people think about control. Because Scotland's experiment was never only about whether a lost species could come back, it was about whether humans could accept what happens after it does.